Hi guys, in this lecture we are going to solve how to solve the reaction at the support indicated by the truss. As you can see, there is there is. First of all, we need to find the reaction at the support. Okay, in order to find the members of of AB. Okay, we have here AF, and we have here BE, and we have here FE, and we have here DE. Okay, here's DE and BC. So first of all, we need to find the reaction at the support. So I will do the summation of so at pen we have here AY. Okay, and we have here AX, and at G there's roller, so I will take AY, GY. Okay, it will be GY. Okay, so let's start finding the support reaction. Then we're gonna solve the force member at each of the joint members. So let's do some measure of moment at G clockwise positive, which is equal to 0. So I will not include the AX since it passed through G. I will include AY, so AY clockwise time by 18, perpendicular distance 10 plus 8, which is 18. Okay, then I have clockwise of 60 plus 60 time by 6 time by 3, and I have plus 45 kilonewton. Okay, 45 kilonewton time by 6 time by 2, and 6 time by 2, and you have plus 30 time by 6. Okay, equal to 0. So by using the calculator is 6 times by 3 plus 45 times by 6 times by 2 plus 30 times by 6. The answer will be AY is going to be equal to negative 100 kilonewton. Okay, so our assumption is wrong. Should be downward. Okay, should be downward. AY is equal to 100 kilonewton. Okay, and we need to find the summation of f of y. Upward force is positive, so it's equal to 0. So you have here gy minus 100 equal to 0. Therefore gy is equal to 100 kilonewton upward. Okay, and then when you solve the summation of f of x to the right positive equal to 0, you will find out that all of these forces, which is to the right, so plus 60 plus 45 plus 30 equal minus ax equal to 0. Okay, so ax is going to be equal to 60 plus 45 plus 30. Ax is going to be equal to 135 kilonewton. Okay, so we found 135 kilonewton. So we found the reaction and the support, and these are the external load. Okay, don't forget, actually, when you do cut method of joint and method of section, don't forget to include the external. So you need to include the external load and the reaction of the support. Okay, so let's start by doing a method of section. Okay, method of section. To do it, you need to do a full cut. Okay, so you need to cut the structure into three members. So one member BC and BE and EY, it is one time. You couldn't cut it at vertically because you have a lot of members. One, two, three, four. It should be only okay. Uh, so um, so three members to cut the truss. So like by using your knife, you can cut by three, okay, three members, and the upward one should be three members. And here we don't have method of section at D since it's only two, okay. And we have here the equation that we can solve method of section. We have three equations that we can solve it with it. We can use summation of moment, okay, when we do cut, okay, sections mean cut, okay. When we do cut, we can use summation of moment, summation of f of y, we can use summation of f of x, okay. um so let's start, okay. I will use the downward part to start with, okay. Let's do cut, okay. So let's do clear, okay. Let's do cut, okay. I did cut, okay. Uh, okay. So you have here long A and G. You either choose the upward or downward. I will choose the downward one since I don't need to draw all of these and it takes time. So I will take the downward one. Okay. So I have yeah, method of section. I would count everything coming out of the joint. So this is joint actually. This is joint connected by the support with roller, and this is also joint which is connected by the support which is pin. Okay, so everything is coming outside. So I assume this is coming outside of it's called FAB. Okay, and the other part which is coming also outside, which I assume it as FAF. Okay, and uh, you have also a G, it's going toward F, so I'm going to target as FGF, okay, and its length is 18 meter, okay. Don't forget to add the reaction at the support, so you have a downward force of 100 kilonewton at A, and you have a force it's going to the right, which is 135 kilonewton, okay, at A. Uh, you can here do dot, okay. I can here do dot. Let's assume this is G, okay. This is sorry F, and I do dot where it's B, okay. So let's start solve it, okay. Remember that my target is in the question that I need to find if the force F represent force of AF and FAB, okay. So uh, in order to find the yeah, in order to find FAB, we need to take the moment at F. So usually method of section to start with summation of moment. To start with the method of section, you need to start with the summation of moment at F, okay. So it's an easier way to start with the moment of with the method of section. Do a summation of moments. So I will say number one, to start with the method of section, I need to start with the summation of moment. Right now, I can either choose a moment at B, but I don't need, I will have two unknowns. So it's better to do summation of moment at F because it will cancel for me FAF and FGF in order to find FAB. Okay, then I will do summation of moment at G. Okay, right now I have FAB. I will do summation of moment at G in order to find FAF. Okay, is everything is clear right now? So let's do summation of moment at F. Okay, summation of moment at F. Clockwise positive, which is like as is the summation of moment at F equal to 0, clockwise positive. So FAB is going up clockwise. It's going clockwise, so plus FAB time by its perpendicular distance to F. Okay, its perpendicular is 8. So this distance I call it is 8, and this is I call it is 10 meter. Okay, and then don't forget here you have here also a force 100 kilonewton. Okay, so I get rid of FAB, then minus 100 counterclockwise time by 8, and then you have 135, which is plus 135 time by um, time by its perpendicular distance, which is 6 meter, and so we have 1 force 2 uh, 3. Yeah, we're left with this force. So 100 kilonewton counterclockwise, so minus 100 kilonewton time by its perpendicular distance, which is 10 meter. 10 meter, it will be equal to 0. So let's do shift solve in order to find it. We did 6 minus 100 time by 10 minus 100 time by 8. Uh, uh, Answer gonna be 990 divided by 8, which is um, equal to 123.75 kilonewton. Okay, so so FAB is going to be equal to 123.75 kilonewton, since it is positive, so I will say tension. So I can write it here. It is 123.7 kilonewton. Okay. So the next step is I need to find the moment at G. Okay, moment at G. So let's I'll do it here. Moment at G. So measure moment at G clockwise positive. So I need to resolve the force of FAF. Okay, so you have here 8 meter. You have upward force of 6 meter. Okay, 6 meter. So by doing Pythagoras, 8 square plus 6 square, so going to be equal to 10. Okay, 10. So if you do by the, let's do it by different color. Okay, um let's take green. Okay, if you do if you resolve FAF horizontally, okay, we don't need it actually. Okay, because it passes through G, so just neglect the horizontal part. Let's take the vertical part. uh, the vertical part will be, okay, let's assume it's going upward. Okay, when I resolve the force, it will be FAF time its sine y, okay? Sine theta, which is y, the vertical part 6, since it is y component, okay? Uh, unlike the frame we usually take the cosine theta, so the x part will be 8. But in trusses and beams, we take the upward one is as sine theta, so it will be y axis, 6 meter, corresponding to the y-axis, uh, over the hypothesis, which is 8. So the hypothesis, okay. So it's going to be this plus this clockwise. So f af 6 over 10, or 0.6, okay. uh, Plus, oh sorry, I didn't do time is perpendicular distance, okay. Perpendicular distance, which is 18, okay, plus 123.7, okay. uh, it's going to be equal, time clockwise, time by 18, you have minus 100 time by 18, okay. That's it. So you have one force, two force, three force. You have three force right now. Here's one, here's two, and you have here's three, okay. um that's it. You don't count anything that's coming out of G or getting into. You don't count it. So this one's, no, no, anything getting into this one, you don't count it. You know why? Because if you shift FGF backward, if it's going like this, it's same thing, okay. It's getting into the force, and then it's coming out, so it's same thing. So we don't count any force that is coming into G. The answer is going to be 123.7 times by 18 minus 100 times by 18. It's going to be, I didn't say 0, so um, minus 426.6 over 18 by 10.8. And so if AF is going to be 426.6 over 10.8 to be minus 39.5 kilonewton. Okay, so so if AF it's going to be, what is it, FAF minus 39.5, which I can say it's compression, okay. So therefore if AF is equal to 39.5 kilonewton compression, okay? Or I can just put it like this one. Okay, where can I go? If AF, I can put it here, 39.5, okay, compression. And you have here, um, uh, the other part, which is, yeah, if AB is 123.7 kilonewton tension, okay. Let's not forget to say kilonewton. Okay, so I found the member, uh, of AB and AF. Let's go with doing section at BC, BE, and EF. Okay. Okay. Okay, guys, I will take the I'll do section. Okay, I'll take the upward. Okay, the upward part. So it will is you have external load of 60 kilonewton. Then you have something like this. Okay, you have here at C. Okay, you have here force, which is 6. You have here 45 kilonewton, 6 Newton. You have here E, and then you extend the line. You say FCB. You have here FEB, and you have here FEF. Okay, so let's extend it. Let's try to extend it. No, let's extend it again. Let's extend it again. Let's extend it till we reach at B. Point B. Okay, and let's extend this one till we reach. Extend it till we reach. Till we reach. But here. This is E. This is F. Okay, till we reach F. So I have here F E F. Okay, since going up at E. Right now, can we solve the structure? If I need to find FCB, I need to start finding summation of moment at E equal to 0 to find, okay, FCB. Let's try to find it right now. Okay, it's here summation. Okay, okay, guys. Summation of moment at E. We will say 60 kilonewton times by, so clockwise 60 times by 6. Okay, and you have here 45 kilonewton not included because it's passed through E. Uh, but I will include FCB minus FCB time its perpendicular distance, which is 8, which is 8. That's it, equal to 0. So FCB is going to be equal to 60 times by 6 over 8, which is going to be equal to uh, 45 kilonewton tension. Okay, since it is positive, it will going to be tension. Let's go and put it here. Equal to 45 kilonewton. Okay, and okay. Now, in order to find FEB and in order to find FEF, I need to take the moment at B. So summation, take summation of moment at B, clockwise positive equal to 0, to find FEF. Okay, so summation of moment at B, clockwise positive, which is equal to 0. Okay, 45 time by its perpendicular distance at B. Where can I find it? 6 meters, so it will be 6 meter. And then you have plus minus. Okay, sorry, it's going like this, clockwise, so it's positive 60 time by 6 plus 6. Okay, this distance 6 meter. Okay, and yeah, plus E plus F E F. Okay, at B it's going clockwise. Time by its distance of 8 meter. 8 equal to 0. Okay, let's try to do it by calculator. 45 times by 6 is 60. 8 times 12 is divided by 8. Okay, so we can find F E F. Okay, is it going to be equal to negative 123.75 H compression. Okay, so just write it as negative. If you need to write it like this, into 5 compression, it's fine. Or you can. It's better to do what, since we say that uh, if the answer is we found the FCB is 45, it's positive. Okay, so I write tension. Here I found it negative, so I write compression. Okay, so uh, to write it here, okay, it's better to say to 123.75 compression. Okay, without putting the minus. But usually, okay, if you solve and you find FEF is negative in method of section or method of join, you will put the negative sign into the process. So let's assume that you need to find something else. Okay, yeah, let's assume this is negative and you say summation of moment at E. So you assume this is negative as compression. So uh, so so I should put it as negative since it is clockwise. Okay, I know if it was negative. Okay, if negative 45 compression, so I'll make it negative. Okay, negative 45. Okay, negative, and it's clockwise, so it's positive. Clockwise. If it, okay, you understand my point, guys? I found that 123.5, and lastly I need to find FEB. Easily FEB. We can use uh, yeah, we can use right now. You just delete everything. Okay. So in order to find FEB, you have the long distance. Okay, CE represent as 8 meter, and um, you have the yeah. If I did cut, okay, this one is 8 meter. Okay, from B to E, and from B to E vertical I have 6 meter. 6 meter. Okay, if I did hypothesis 6 square plus 8 square, it's going to give me 10. Okay, so let's do some okay, if I did summation of f of y upward force, which is positive, Yes, guys. You have force. I did. We did summation of f5 equal to 0. Right now it's minus FEF. Okay, as told you, it's compression. Okay, now I will put FEF uh, as negative 123.75. Okay, so it will be negative 0.6 FEB. Negative time negative, it will be positive 123.75 minus 45 equal to 0. So 123.75 minus 45 is going to be equal to 0.6 FEB is going to be equal to 78.75. 0.6 FEB equal to 131.25 kilonewton. Okay, guys. So right now we found FEB. Where can we find FEB? It is its tension. Don't forget to say its tension. So it is positive. Okay. So we found this beam. It is the FEF was FEF. FEF. Okay. It is 123.75 compression. Okay, it's E. Okay, and we found also EB, which is 131.25 kilonewton. Okay, let's find here the joint at D. Okay, let's finish everything. Okay, method. Guys, right now, uh, method of joint. Method of joint can be solved by only two two unknowns, two equations, and two unknowns. Two equation, which is summation of f of y and summation of f of x. Okay, summation of f y and f of x can be solved. We can do some the moment summation of moment. Okay, so at D, it's everything is same. Okay, even okay, it's the external force of 60 kilonewton external force, and we have downward force, which is FDC. Okay, which we can say dotted into C. Okay, and here we have a force, which is saying FGE. Okay, let's continue as E. Okay, so we assume the joint tension as we did in method of section, but the difference is we have only two unknowns. Okay, so FDE and DC, but in method of section we have three unknowns. Okay, and method of joint we only can solve it by using summation of f of x and summation of f of y. Um, to solve it. Okay, so let's resolve the force right now. Right now, the length I'm doing right now, triangle. Okay, instead of finding the theta, the length of DE, the horizontal length of DE. Let's see it. Okay, it is from the tip of D till E, till joint E will be 8 meter, 8 meter, and from the tip of 8 sorry, from the tip at joint E to D, it's going to be 6 meter by doing Pythagoras. Okay, 6 square plus 8 square. It's going to be equal to 10, okay? So it's going to be equal to, it's going to be equal to 10. So let me remove this thing, okay? Equal to 10, and I call this fd. Let's resolve the force, okay? If I resolve the force, okay, this is downward, this is downward, okay? Uh, you have here FGC, okay? And you resolve it again. Sorry, you resolve this one, DE. So FGE is going to be equal to 6 over 10, okay? And if you resolve horizontally, FGE is going to be equal to 8 over 10, okay? And you have the 60 kilonewton. This is D, joint D. Let's see, joint D, okay? Joint D, you have also 60 kilonewton. Let's do summation of force F of X. Let's do summation of force of F of X equal to 0. The right side positive. So I have right side 60 plus FGE times 0.8, okay? Which is equal to 0. And you have here right now 60 divided by 0.8. F G is going to be equal to negative uh, 75 kilonewton compression, since it is negative, okay? uh, right now we can solve a summation of uh, yeah, FDE. FDE we can find DC, but no need. The question they didn't say, but let me add it, okay? Okay, and okay, let's say DC, also DC, okay? So let's do summation of f of y. Upward force is positive is equal to 0, so we will have negative FDC, and we have negative FDE, okay, into 6 over 10 equal to 0. Right now I'll substitute FDE with negative 75. So this I'll substitute negative 75. Okay, so here F, negative FGC, negative time negative will be positive 75 into 0.6 equal to 0. So 75 into 0.6, okay, and the answer is going to be FGC equal to 45, okay? This is kilonewton tension. Okay guys, thank you guys.